To today's webinar. We'll get started here in just another minute or so. I see some more people trickling on in. If you don't mind, go ahead and adjust your speaker volume, mute your microphone, and also go ahead and locate that question panel most likely on the right of your screen. So if you do have any kind of questions, if you can't hear me, if something's going on with the presentation, feel free to write questions in there and give me a heads up. And if I don't answer your question right away, just know that I do see it and I will answer it maybe at the end of the webinar. So, all right, thank you so much. We'll get started here in just a minute. Okay, everybody. It looks like it is that time to get this webinar started. A big thank you to Rick Smith, our marketing director, who will be recording this session. Do know that these slides and this webinar today will be recorded and placed on our YouTube channel if you'd like to view it again later. Let's go ahead and get started. All right, hello and welcome. Today's webinar is going to be on why having a good safety requirement specification is a must for machine safety. Sure, we've talked about a lot of process industries. We talked about cybersecurity alarm management, but today I do want to specify more for machine safety. My name is Ted Stewart. I am the program development and compliance manager here at exida. One moment here. Let me start over real quick. I did forget to hit the record button, but my name is Ted Stewart. I am the Program Development and Compliance Manager here with exida. I do have roughly 10 years of experience in the safety and high availability automation systems, manufacturing, lean process improvement, and my roles for exida are, I do wear a lot of different hats. I manage the OEM certification division. I'm the Deputy Quality Manager, who basically I help with all the ANSI audits for our accreditation, and I am also the director of the CFSP program. Now, exida is involved with the complete supply chain of functional safety in basically multiple different industry sectors, anywhere from the original equipment manufacturers who actually require this product certification through to end users that use the products. Now, exida provides software tools, we provide trainings, consulting, and procedures related to functional safety, related to security, and also reliability. You'll see here, this is our products and our suite of services that we offer. For consulting, we have process safety, alarm management, cybersecurity, machine safety. We have many different engineering tools, which I have a slide on with more depth as to the types of software that we can provide. We have product certification, which is actually something that I am very active with, as far as 61508 certification, cybersecurity certification, also machine safety. We have training. Basically, we have any kind of training at least once a week somewhere in the world it's going on. So we're very heavily in training. It's increasing more and more. We have reference materials. The idea with our reference materials is we like to publish everything we can because we want to become an open book. Anything that we know, we want you to know, and that's why we publish everything. And also for our accreditation, anything that is public information, we are allowed to use and share with you, and we will not impede on, or we will not be impartial to that accreditation. And of course, we have professional certification as far as for people, like the CFSP program, CFSP. We have CACE and CACS for cybersecurity, and many others. With personnel certification, even in the new standard of IEC 61511, it's partially released. You will also notice that they're becoming much stronger on the requirements for personnel competency. A couple more quick slides about exida before I get into machine safety, only because we always have some new people on these webinars that are unfamiliar with our company, so we like to throw these slides in here. But basically, exida certification, we've established schemes for functional safety and cybersecurity for the systems, for the products, for the components, and for the people. And for functional safety certification, it does involve a detailed analysis of two different things, the engineering process and also the design strength margins. And within cybersecurity certification, which is an up-and-coming certification, this involves a detailed analysis of the engineering process, cyber defense mechanisms, and basically your network robustness. Here's the reference materials that I was talking about. We do try and publish everything that we can, so that anything we know that you know. And if there's any subject that you feel is not well covered in any kind of book, let us know, because we usually have a few people in our company that are constantly writing books and trying to get everything on paper so that we can get that information out there to you. Some of the tools, this is something that I'm actually learning to be very fond of. I love our tools that we have. I haven't been too involved with it in the past, but I've started to learn more and more about what we can offer. And wow, it make your job so much easier. So the one that for today, we're talking about the Safety Requirements Specification, and would you believe it or not, we actually have a tool that will help you create one of these. And when I go through this webinar, you know, this SRS, it can be overwhelming. It can be a lot of work depending on what type of product you have, what type of process you have, what type of plant you have, and if your plant changes locations, if you're a global company. So we're going to get into that SRS right about now. So I know I spoke previously, but if you do have any kind of questions, you do have a tab there. Go ahead and ask questions away. If you can't hear me, if something bogs down, let me know as well. That would be great. And let's go ahead and get into this presentation. We're going to be speaking about the definition of an SRS, the requirements, the format. I'll ask a couple questions, throw some solutions, and go through some questions as well. Okay, here we go. Before we really get started, I love to at least show the difference in terms, because many people are familiar or are getting more familiar with IEC 61508. They're getting themselves familiar with IEC 61511. However, with machine safety, of course, they have their own standards and their own wording. Today, I'm going to be more speaking, because I had to pick at least one standard so that I can so I can become consistent. I'm going to use IEC 62061, which is one of the machine safety standards. It's more for complex systems. ISO 13849 is more prescriptive, and it's used mainly for more simplistic machine plants, machine systems. So basically what I wanted to show you is the language. It all means the same thing, just slightly different in each standard, because different committees like to call them different things. So in IEC 61508, a safety-related system is the same thing in 62061, which is a safety-related electrical control system. Same thing with the safety function in 62061 is the safety-related control function. And 61511, of course, if you know a SIS or a SIF, it's the same thing as a safety-related electrical control system and a safety-related control function. So I hope that's not confusing. I hope that did clear some things up, because as I go and I speak, I am going to be using 62061. So what is an SRS? Well, the definition of an SRS, it's the specification that contains all the requirements of the safety-related control functions in the safety-related electrical control system, right? So the objective is it specifies all the safety functions with the safety system requirements that are needed for that detailed engineering and machine safety information purposes. And so basically, let me just summarize and say it like this: the overall objective of this SRS, it's basically saying, everything needed to allow for safe and effective realization of that function, and that some even say, oh yeah, that's a lot of stuff. There's functional requirements, there's integrity requirements. There's also a contractual document prepared by one company, it's executed by another, and some people have called the creation of this document as an administrative burden, and we get that a lot. We understand, but those that do a great job with their SRS, they realize that a complete, clear, and accurate SRS will actually save them a lot of misunderstanding and rework. And one way to minimize the effort and maximize the benefit is to use cell selection, risk and hazard analysis, work process templates, and then that way you can generate the most of this SRS at a more of a direct output. And we'll go into more details. So where does it lie in the safety cycle? The safety life cycle. Well, if you look at it, it's at the very beginning, towards the end of the first section. And if you see here, you're going to basically define your machine scope. You're going to identify the potential hazards, the consequences, identify protection layers, likelihood analysis, figure out if a safety function is truly needed for that risk. If it is, then we'll identify it, we'll create a risk reduction factor, we'll target your SIL ratings, and then after everything was identified, we'll develop this safety requirements specification. And in safety-related electrical control system, it's designed to automatically protect an industrial process, and the steps required to do this cannot begin until this conceptual design for the process is complete, right? And a description of the needed safety function along with all the important information, including that SIL information in this SRS, is how you basically get the conceptual SRS up and running. And mind you that these SRSs, this document is not something that you do once and you forget about. It becomes a living document, and I'll explain the difference times and when you want to look at this SRS to keep it updated. All right, so on your safety requirement specification, one of the overview slides that we have here is that you want to make sure all your input from all the previous phases are written down. Your risk assessment, you have your risk assessment results, your machine characteristics, your description of each function. You want to make sure you specify the requirements. If it's the mode of operation, is there response time? You can talk about process time in there, your cycle times, your HMI interaction. And then, of course, you want to get into your integrity requirements like SIL, test requirements, and your software safety requirements. And one other thing that I would like to specify, and I do say it a little bit in a different slide, is that documentation it does not fix bad management, okay? It only gives such management new opportunities to, let's just call it, to fail. And the SRS and other similar documentation needed to be part of a well-managed project in order to add value, right? So you want to have the right people in line creating this document. So for lack of better words, garbage in is going to be garbage out. And if you don't have the right people creating this and specifying the requirements, you're not going to achieve what you would like, at the beginning. So the better you can prepare yourself, the better you can have the right people involved with creating such a document, the more time, effort, and money you're going to save in the long run. And more value. Very interesting chart here from HSE out of the UK. Basically, this chart here explains when an incident happens and what percent and when it usually occurs. Well, look at the big yellow part on your screen at the bottom. Specification. 44% is basically because something was not well defined. You also can look at 15% more of that with design and implementation. Right? So there's right there 60% truly because something wasn't thought out, something wasn't specified, the implementation, everything there at the very beginning of this product was because, why? They didn't have it defined. So that's why we really want to stress the importance of such a document. Is it a document that is required by any standard? No, it's not required. It's strongly recommended, and you'll see why we would like people to develop more of these SRSs, because it's going to make things more efficient, more clear, more precise, because there's a lot of requirements needed to get either a product certified or to meet the standards that are out there today, like IEC 62158, 62061, 13849, and having all of your requirements at least in one area that can point to other documents will save you that time. Now, the SRS is the source of all knowledge, right? So when developing this type of SRS, all of the information generated during this analysis phase of the safety lifecycle is going to be needed. And this is going to include all the process or machinery information, any potential hazards, especially your regulatory requirements, right? If you're not thinking about it, in the United States, our requirements is basically saying, OSHA, who says use best practices, which is great. They're not too restrictive. There are some standards to help guide us. But let's say you travel to the UK. They're much more strict on their standards. Their standards, if you're working on a CNC lathe, there's standards if you're basically any type of safeguarding. And there's going to be standard that you must follow per their regulations. And so you need to figure out, if you're a global company, and say you have some things in Australia, you have some facilities in the UK, maybe some in the United States, make sure that this SRS identifies these regulations and how they're going to change depending on where that plant's located, or pick the stringent one and just make everything, make that your framework. So now no matter where you operate, you're going to be compliant to any industry around the world. So that's something to think about. And then, of course, you want to list all of your safety-related control functions, right? So for each safety-related control function, the required risk reduction, usually in the form of a SIL, and the risk, the rate of risk analysis information will be required. So here's a fun slide. This is one that we've used on previous webinars, but it gives a great visual of communication and specification, right? Because specification on that slide was 44% of all of the incidences were because it wasn't specified clearly. Well, let's just say, you're talking on the phone and all of a sudden the customer says, hey, this is what I want, okay? So then you say, okay, well, if you want this, I'm gonna sell you this, right? And so usually people will oversell a customer and it looks like this. And then, well, how does it actually get designed? Well, communication wasn't too clean, so this is how we think it should be designed. Well, how is it going to be built? Well, might be impossible, but this is how we're going to build it. Well, how was it tested? Well, why don't you just put the swing on the ground? That's good enough. Let's go and say that's how it should be tested. How is it documented? Sad to say, but this is usually what we run into. It's usually in someone's head that's been at the company for 40, 50 years. I know exactly how this thing should be. It's all up here. Don't worry, it's safe, right? And so this is what we normally see with how it's documented. How was it installed? Well, whoops, they might have forgot a few things. How it was billed? Well, they kind of got billed for a roller coaster. How was it maintained? Just chop it down. We don't need maintenance. We don't need an impact analysis. And then, of course, what the customer really wanted. So you can see, if we had the communication, we had the framework in place, you put the restrictions, the requirements, the guidelines, for your functional requirements, your integrity requirements. Now we can have a better picture of what the customer truly wants and what our organization really needs to save us that time and money. And that's just a fun way to show it. And yes, this SRS is a living document. It's the backbone. It's not just for that project implementation and testing, but also a key point of reference during the operational phase, right? So the SRS, it needs to be clear, concise, complete, and consistent. Stay away from those three-letter acronyms. You know how I say SRS, but mind you, every time I say SRS, I usually try and say it out so that people know what I'm speaking about. So when you have this document and you're constructing it and you're meeting all the requirements to these standards, make sure if you have common acronyms, they're not common to anyone else. Just assume but then to you, right? So, or you can have an acronym sheet that explains every single acronym so that when someone reads your SRS, your Safety Requirements Specification, it doesn't bog them down and take them longer to get through this already pretty intense document, right? You want to make it clean, precise. Doesn't have to be any kind of page limit. You want to make sure it tells what you need it to tell in the most efficient way. All modifications should also be evaluated against this SRS. So when you're going through and you're in the operational phase, take a look at that SRS, and when you make a change, go back, make sure that you're meeting the requirements of what you specified at the beginning, because the better the background information that you have in this document, the more informed and the more impact you're going to have moving forward, right? So I would also say if there's something that could be confusing, right? You have a process that you have, and even you yourself say, man, that is kind of confusing. Why do we go from stage 1 to stage 3 and all of a sudden we go to stage 9? Well, if something is really confusing to you, it might behoove you to create some type of index, annex, something in the back of this SRS or wherever you want to put it, and put a note and state why that process is the way it is. Therefore, if somebody comes in, say they're newer, you know, every 3 or 4 years, your company, it's a large organization, they're always switching people around, moving people, because that seems to be a trend nowadays. When this new person comes in, they see this SRS, make sure that they can look at it and say, oh, that's why they're doing that. Don't be afraid to add a little bit in there if it's value added. All right, and so here are some of the input requirements that you want to put into this SRS. The Safety Requirements Specification step occurs after, right, the assignment in the safety life cycle. We talked about that. You want to put the machine information in there, the risk assessment, your target cells. You want to list the safety-related control functions, and within those control functions, the hazards, the frequencies, the consequences. And besides these input requirements, you're also going to have functional requirements and integrity requirements. Perfect. So here are the functional requirements. Now the SRS should contain, and on these slides I kind of give a like a checklist approach, a bullet points, because after this webinar, if it gets you thinking, hey, you know, maybe I should take a look at what our document has, or if I can find our requirements, and I put in this form so you can go back to this slide and say, okay, do I have the machine operating mode for that safety-related control function? Do I have one for all safety-related control functions, or do I really only have one function with my system? You want to look at to see if you have the priority of functions that can be active at the same time. Why? Because you want to avoid those conflicts. Make sure that if one does take priority, that it truly gets that priority that it needs. Let's say, for instance, you have that e-stop, the emergency stop button. Make sure that's on its own independent line. I don't know if we speak about it in this webinar, but make sure that when someone hits that e-stop, something else doesn't get priority over it, and you can't actually stop that system down to prevent whatever hazard is starting to occur. Operating environments, right? So if you do have a facility where you need to move the facility to a different location, or you have multiple different facilities, make sure you identify what the operating environments need to be and what the requirements are for that. So if you have one in a desert, or you have one over, let's just say like close, like subsea or onshore, or in a wetter location, how does that affect your plant? How does that affect how you operate? You're going to have more dust particles and debris if you're more in a desert, and you'll have more humidity, let's say, if you're at a wetter location. So you need to start thinking about these things. You want to make sure you talk about your safety requirements, your control function descriptions, right? So for each control function, have a description in there. What about the frequency of operation for each one of these functions? What about the response time, the process time? You can talk about the fault reaction function, right? To stop a machine, if there's a loss of power, what happens if if you just because you stop something, does that create a new hazard? You know, if you have any kind of gas in a tank and all of a sudden you stop it, does that, if it stops immediately, is that going to explode the tank? Because that's a different process, right? Is it used to doing that? And so these are some things that your team will come together and do a risk assessment and develop, and identify these types of hazards if anything were to occur. And then you should also have requirements when you were to reset your plant and turn the plant back on. What are the requirements and what do you need to do to make sure you can turn the plant back on in a safe manner? All right. And I do have a question in here stating that that this presentation does focus on 61508, but how would you address the same needs under ISO 13849 and 26061? Well, hopefully these slides as I go through it will identify, but do remember that 61508 is that umbrella standard, so a lot of, even in 62061 and even in the new standard of 13849 that came out in 2015, they're all looking at 61508 to help them build their standard. So keep that in mind, because you will see some parallel efforts in the process industry and in machine safety. But hopefully you'll see enough in here because it all applies, right? In machine safety, this will apply because what you're addressing is even a different webinar where I'll talk about performance levels. I can talk about categories. I can talk about how different ratings are used for those types of standards. But for the SRS, there is going to be some crossover from 08 and 13849 and 62061. So hopefully through this webinar, you will be able to see the differences. Now, let's talk about the integrity requirements. The SRS must contain these integrity requirements. Why? So for each SIL, that safety-related control function needs to be derived from that risk assessment. There are requirements for diagnostics to achieve if there are requirements for the diagnostic to achieve this required SIL, look for the requirements for maintenance and testing to achieve, and then of course your reliability requirements if spurious trips may be hazardous. Now, when you talk about software, you have certified embedded software according to 61508 Part 3, right? So you have PLCs, many systems are available. You also want to take a look at the sensors and final elements. There should be limited devices available. You want to specify the software language for the logic solver. For example, there's 3 from 61131. You have ladder, you have functional block diagram, sequential functional chart. And in software, here's another little checklist that you have to help make sure that everything is included, right? So when you're speaking about software for that safety-related control function, you want to specify the logic, the input and output of the function blocks, the format values ranges for the I/O, any relevant data for the functional block limits, the response time and limit values, the diagnostic functions. You want to take a look at the fault detection and enunciation, periodical test requirements, capacity, and response time performance, any limitations on programming, and of course references to those PLC safety manuals as needed. And nowadays, any product that is certified will have that safety manual. So if you do purchase something, make sure you get the safety manual that has all these specs that will help you to, you can then put those into your SRS as they apply or as they are needed. So the different type of logic description methods, you have 3, and they all have their strengths and weaknesses. For the strengths for plain text, well, it's just plain text, right? So it's going to be extremely flexible. There's no special knowledge required. Anyone can read it. The weakness, though, it's going to be time consuming because you have to make sure that you write exactly what you intend the objective to be. The transposition to program code is difficult, right? And it's error prone because you have to make sure that when you transfer this over, it's exactly how it needs to be. So that is a big weakness. The cause and effect diagram is probably my favorite. The strength is it's a low level of effort. It's clear visually. I'm a very visual person for representation. The weakness, though, is that it has a rigid format. You can't necessarily represent in a cause and effect diagram like you want to. Sometimes it's restrictive, right? You can actually oversimplify because you can't put too much detail in it. but it usually does the job depending on your program, your system there. The binary logic diagram will show an example of that. The strength is that it's more flexible than your cause and effect diagram. It's a direct transposition to that functional block diagram program. However, because there's a lot of different symbols, it can be time consuming to try and figure out how to draw it up. There is knowledge that needs to be known. So if someone walks in and they don't really understand a binary logic diagram, they're going to have to learn before they can even read that diagram, which isn't a big deal, but it's just another step, and it is a weakness of that. So here's an example of plain text, right? So as I'm writing and I want this to be put into code, I need to be very specific. So here's how I would write it. I would say, if one of the following conditions occur, switch BS01 is de-energized, indicating loss of flame. Switch O2 is de-energized, indicating loss fuel of gas pressure. Then the main fuel gas flow to the heater is stopped by performing all of the following. Closing valve 03A and 03B and opening valve 03C. Okay, so I'm performing actions here. The respective valves will be opened and closed by de-energizing the solenoid valve XY03. So this is my process. This is how I would word it, and this is how I would then put it into code. But you can see the flexibility. I can say as I want and create my scenario. If I were to create a cause and effect diagram, it would look more like this. It's more simplistic. You can kind of just say, here's my tag numbers, here's my descriptions, here's my requirements, and then as things happen, you know, if say the burner loss of flame, then it's going to close valve 03, it's going to close valve 03B, and then it's going to open valve 03C. So it's the same thing. It's a, you know, it's more visual. You can see it, and it's an easy representation, in my opinion, to get let's just say my story across. If you're, well, before I get to the binary, and here's another thing that, you know, as I'm learning more about our tools, I could simply just put the inputs in Excellentia and it just spits out this cause and effect for me, and then I can have them all saved. I can just slightly modify it if I have more safety control related functions, so I can create all my different cause and effect diagrams, which is kind of nice in these types of tools. And here is a binary logic diagram. As you can see, if you're not familiar with them, it could look a little confusing. But as you go through it, you identify your inputs, right? You go through, you create your input field, your logic solver, your output field, and you can see how, when, if it fails, if it closes, if it fails, open. But you know, the logic can also be expressed basically with this diagram, where the drawing generally takes the most time, but it gives you that more precise description. And the logic shows that the nature of this, right, the de-energized to trip application, if you're reading the textual description, one might actually use the word or to describe the logic, okay, instead of and. And for example, the valve should close when BS01 indicates a trip, or when PSL01 indicates trip. But here's the thing, these signals go to the logic 0 when the trip is indicated. Therefore, you actually have to use an AND gate, and that's per one of the theorems. I think it's De Morgan's theorem. That's just one of the caveats. So, like I said, there's a learning curve when you write these out. So that's just, but if it helps you clearly express your needs, then this is the right form for you to use. Here's a sample of conceptual SRS. You can see how they've identified references, what each safety-related control function needs to say. So you have the tag, which is, hey, it's a new SRCF. What is it? It's a guard interlock. The equipment's a CNC lathe. You go through, you can see the integrity level, the required risk reduction factor. You'll see what else is on here? If there's a startup override, right? So it says does not need to operate the spindle speeds under 10 RPMs. And then what's also a good note to see is that you have this one document, but you can point to other places in other documents. So if you look at T, U, and W, which is maintenance overrides, operating modes, and mission time, you can see that it's pointing to other documents and other sections so that you don't have to keep everything in one place. If you already have it somewhere, this is just a great directory of where to find that information to meet that requirement to make it more clear and concise. For an SRS summary, there's some general requirements and there's more specific requirements. We touched on a lot of these already, but just to have them all in one location, you're going to see that for a general system, you want to write in what are the non-functional, what are the regulations and standards like we talked about. If a failure occurs, what are they? What's the start? What's the restart? Are there interfaces? Environmental conditions, where's that plant located? And then general for that safety function, safety-related control function is your maintenance overrides, your manual shutdowns, okay? You know, those e-stops, the operating modes, your failure modes, your resets, your diagnostics, and of course, more specific for each and every safety-related control function. You can't just do one and use it across the board. You want to make sure you do one for each and every function your system has, but you need to identify it, you need to write a description, define that safe state, if it need, you know, for the required SIL, the proof test interval, your response time, your architecture, I like to say your process time too, your mode of operation, right, if it's energized, de-energized, demand, or continuous. Usually you'll have high demand or continuous. And machine safety, notice your trip rates and logic, spurious trip, startups, and special requirements. And like I said, I like to put everything in these slides so that you can go back and take a look, and then when you start creating it for your plant or for whatever, you have this list here to help you. Like I said, I've been learning and loving these tools, so you can see here next to Excellentia how you can just put all the inputs in. It develops this screen here. You can write reports with it. You can create your own SRS, and for this one you can see the diagnostics. You can see the process connection if it was clean. What kind of architecture, you can identify the components, the tags that you want to use or have used, and it's a really great tool. All right, so not everything is nice and clean because there are problems within an SRS. You know, your hazard and risk analysis, if it was poorly done, we did have someone comment on that earlier, but if you have it and it was poorly done, that does provide bad input for that SRS, right? So you can have misidentification of that safety-related control function. You can have incorrect selection of SIL. And if you're not defining all failure modes and protection requirements, you're going to have actions of functions that don't actually achieve that safe state like you thought they would. You'll have measurements that might be too slow to pick up and prevent an accident if you have the wrong timing. Right, so then also not defining all operating regimens. If your startup, your shutdown, you could be missing the environmental conditions, and of course, poor revision control. I think documentation is pretty key, and we just visited an organization last week, and you know, documentation. It's, hey, oh yeah, that sounds like a great idea, but we don't really do it. And if you don't maintain, then that's, you know, then you're going to have to start all over, have a learning curve. You're going to need to figure out where to find your requirements, your documents, and it always is a good idea to at least start if you haven't. And of course, you'll have conflicting or missing requirements. Some could be safety, some could be non-safety actions. So these are just some things that if you don't take it serious at the beginning or have the right people involved, you could and will run into issues later on. How do you avoid? Well, there's nothing that specifically states in 62061 or 13859, however, or 13849, sorry, but in 61508 and dash 2, the second part, they do have some help where they talk about program management, they talk about your documentation, they talk about how to separate safety and non-safety functions, your structure specification, your checklists, which is probably my favorite, is a checklist. I mean, have you ever seen, or maybe you haven't realized, but every single time you get into a plane, those pilots have a checklist. They don't care how many times they've done it or flown, they have a checklist they go through every single time. And that's how we should get ourselves just to develop that habit. And then, of course, your semi-formal methods, your logic diagrams, sequence diagrams, etc. Now, the SRS, the quality, the only thing I want to say here is that it doesn't really matter how many pages this document is. It can be 5, it could be 9, it could be 30, whatever it takes to basically get you a precise, a quick, and clear document that will help share information with that person looking at it, where all the information is needed for the requirements. And that's the biggest thing. Of course, everyone has their own templates. There's nothing in the standard that says it's required. However, to meet all the requirements is required. So how easy you want to make that for somebody, or how precise, or even how many locations you have around the world, you want to make sure everyone starts with the same framework. Now let me ask you a couple quick questions. There's 2 of them in here just for some fun to help. But basically, as the safe state of an equipment under control for each hazard should be contained in an SRS. Is that true or is that false? That a safe state of the equipment under control for each hazard should be contained. It's true, and it's a little tricky of how it's stated, but although IEC 62061 doesn't explicitly mention the safe state for that equipment under control, it does require that a description of each safety-related control function, right? So it requires this description. Now in 61508, it does specify the state that the SRS must, in quotes, include the manner in which the EEPE, which is the electrical, electronic, or programmable electronic, safety-related systems are intended to achieve or maintain a safe state for the EUC. So in a roundabout way, if you read 62061, it relies on 61508 to basically specify, yes, you need to include the safe state in the equipment under control for each hazard. All right, so an injury may occur if a person walks into an active area of a robotic welding machine. A perimeter is established with personnel sensors around this machine such that a person takes 1 second to walk into the dangerous area. The machine cycles every 5 seconds. The process safety time is what? So this could be like a light curtain. So if the person takes 1 second to walk into a dangerous area, the machine cycles every 5 seconds, what's the process safety time? It's actually 1 second because the process safety time is actually that time period from sensing a dangerous condition. So even though that machine is rotating every 5 seconds, it's really the time that it takes for that person to get themselves into a dangerous event that could occur. And it's commonly mistaken, but it's a definition, and so the process safety time is 1 second. So as you said, I did go through the definition, the requirements, the formats, the problems, and solutions. And that concludes our presentation. I believe I answered the questions as we went through. I did have some quick little information in front of you. If you need any more information, also, if there's anything that was unclear, if you would like to email me, there's my email in front of you at tstewart@exida.com. And I will look into, I do have a question here, challenging that the 1 second is the safety function response time. I believe it's also the process time as well. And so, Doug, I'll look into that too. But yeah, no problem at all.